Well, we're ready to start a new chapter, Chapter 10 on analytic geometry. Now, we're only going to spend one chapter on analytic geometry, so count your blessings. When I was in high school, I had to take a whole semester of it. We start off with the idea of the conic sections, and the first conic section that we're going to talk about in this chapter is the ellipse, although we have already talked a little bit about one of the conic sections way back when we were talking about circles. Now, the conic section kind of gets its name from a double nap cone where you cut a plane through it at various angles and at various places. Like here, if I cut straight across, I would get a circle. If I cut kind of on an angle, which I tried to draw, it's very difficult for me to draw to begin with, and trying to draw 3D on 2D is tough, and you get what looks a little bit more like an oval shape, or what we call an ellipse. If you're able to cut through the plane downward like this, you get the idea of a parabola, which we've also talked about. And then if you bring it straight down, kind of perpendicular to like the center rod on a double nap cone, then you get two shapes, two U-shapes, which is a hyperbola. And we're going to talk about all of these in some detail, although we're going to spend most of our time not with the circle, I'm going to define it here, but in this first section with the ellipse. Standard form for the equation of a circle. Given a circle centered at HK with a radius r, the standard form of an equation of this circle is given by this. This is this equation, the quantity x minus h quantity squared plus the quantity y minus k quantity squared equals r squared. Center radius form or standard form. We've dealt with this already. We know that a circle is a locus of points or a set of points on a plane that are a fixed distance from a fixed point. The fixed distance is r, the fixed point is the center, r being the radius. Now if we take it off the plane, then we get a 3D shape, we get a sphere. But that's about as much as we're going to review on the circle here. I'm going to jump over to the ellipse, which has a slightly different definition. An ellipse is the set of all points in a plane such that the sum of the distances between a point xy and two fixed points is a constant. And the fixed points, as I've got written down here, are called the foci of the ellipse. You're liking the shirt, I'm sure. The foci, that's the plural, singular is focus. As you can hopefully see, I have a piece of string that I've taped to the wall. Now I don't know how good this is going to go, because normally when I do this, I have students that hold these points a little bit more steady still. And before I try to draw, what I'm going to hopefully be able to show you is the shape of an ellipse. Again, it's kind of an oval shape. These 2 points where my tape is at, those would be considered the foci. So I'm going to grab a pen. Let's use a brighter colored pen here. This time let's try the green. And I'm going to use this string, if I can grab it, that is. Maybe I can. There we go. I'm going to use the string here as the distance between a point and the fixed points. This piece of the string and this piece of the string. And according to this, the sum of these 2 distances is going to be a constant. Well, it's definitely going to be a constant because the string isn't changing. I've got it taped, I've got it fixed, so that this distance here of the string in between where I've got the tape is fixed. Now normally we call that 2a, I'm going to explain why in just a second, but I'm going to put my pen inside the string and I'm going to use the string and I'm going to try to draw it somewhat taut. Now, you got to try, oh, see it slipped already. You got to try to keep a little bit of tension on the string so that you get a nice steady drawing. And that could have been worse. And you get the oval shape. Now, how much string is left between the 2 fixed points and how close the points are to one another, that's going to make a difference in kind of your shape. I put my 2 foci here, looks kind of on a horizontal. You could have your foci on a vertical as well, or you could have them angled off. We're only going to really look at the ones that the foci are on a horizontal line or on a vertical line. In fact, if you look over here at this drawing, I'm going to try to kind of derive the equation of what an ellipse is. Now, the way I've got this drawn here, I have two fixed points, F1 and F2, that are fixed distance C from the origin. Just for convenience sake, I'm making the origin kind of right the midpoint of the line segment that contain those two foci as endpoints. This is going to be called, just like we have the center of an equation, this is going to be called the center of the ellipse. You can see the center of the ellipse would be right smack dab in the middle over here with my drawing. Now over here, I'm going to have all points, and I'm going to graph one point here, and I called it point xy, such that this distance plus this distance is some set amount. Now, this is C, this is A. I've got C and A both positive, and I got A bigger than C. All right, this fixed distance turns out to be 2 times A. Now, here's how we're going to go about to try to show you that. I'm going to write, using the distance formula, PF1 as the square root of the distance here, x minus the opposite of C quantity squared. Actually, this is PF2. Let's do PF1. So it's this point right here. PF1 would be, yeah, it wouldn't be negative, but it would be squared. Here, let's try that again. Since I've drawn started off with such a poor start here. Let's see. I'm going to have x minus C quantity squared plus y minus 0 quantity squared. That's PF1. Plus now this distance, PF2. That would be the square root of. That would be x minus the opposite of C quantity squared plus y minus 0 quantity squared is equal to 2a. A again is the distance from the center to this point right here. So now, what am I going to do here? I'm going to simplify. I can go ahead and multiply it all out. This would give me x squared minus 2xc plus c squared plus y squared plus the square root of x squared. Now subtracting a negative is like adding the opposite here. So this is x plus c quantity squared. So this would be plus 2xc plus c squared plus y squared is equal to 2a. Well, I want to get rid of the radicals, and to do that I'm going to have to bring one radical to one side. So I'll toss this guy to the other side. X squared minus 2xc plus c squared plus y squared is equal to 2a minus this radical here. X squared plus 2xc plus c squared plus y squared. Now I'm going to square both sides. So, square this side, square this side. That'll get rid of the radical. And I get x squared minus 2xc plus c squared plus y squared equals, now I got to do a little FOIL action here. This is going to be 4a squared minus 4a times the square root of x squared plus 2xc plus c squared plus y squared plus the last one squared, that'd be x squared plus 2xc plus c squared plus y squared. Now for convenience sake, I'm going to subtract x squared from both sides. I'm going to subtract y squared from both sides. I'm going to subtract c squared from both sides. Alright, so that will give me, over here on the left, negative 2xc equals 4a squared minus 4a times the square root of x squared plus 2xc plus c squared plus y squared plus 2xc. I'm going to subtract 2xc from both sides, so that would give me negative 4xc is equal to 4a minus 4a times this radical. What a mess. And now I'm going to subtract 4a from both sides. Because I'm trying to get the radical by itself, I have to square both sides one more time. Okay, I'll divide through by negative 4, so that will give me xc plus a is equal to a times this radical here. Okay, I am going to See, did I do everything right? I subtracted -4. Okay, yep, looks like I've done everything right. Now I'm going to square both sides. So that's going to give me x squared c squared plus 2xca plus a squared on the left. On the right side, I'm going to have a squared times the quantity x squared plus 2xc plus c squared plus y squared. So if I distribute through, x squared c squared plus 2xca plus a squared is equal to a squared x squared plus 2xc a squared plus a squared c squared plus a squared y squared. Oh man, what a mess this is starting to look. But one nice thing, I can subtract 2xca squared from both sides. I'll go ahead and cancel those right out. And I think that's as far as things canceling out. So I'm going to get everything with x's on one side, x's and y's on one side, and all my constant terms on the other. So that's going to give me here x squared c squared. That I'm going to throw on the other side. I'm going to bring this guy over. Minus a squared x squared minus a squared y squared is equal to, now I'm going to throw the a squared on the other side, so that's going to give me a squared c squared minus a squared. Unless I wrote down something wrong, I think that's it. Feel like I'm missing something. I haven't done this proof in a while. I hope I didn't mess up on you guys here. So that came over, that came over. Alright, I'm going to factor out an x squared here. X squared. And that would give me c squared minus a squared. Yeah, something tells me I'm messing up somehow. But we'll find out in a second here. See, so that's going to be minus a squared y squared is equal to, I'm going to factor out an a squared here, if I'm not mistaken. Feel like I got to have a fourth somewhere, something to the fourth power. I multiplied by a squared here, a to the fourth right here. There it is. Just didn't look right from the get-go. So that was a 4 there the whole time, so that's a 4. Here we go. Now we're cooking with gas. Factor out that a squared. That leaves c squared minus a squared. Now up here, I'm going to make a substitution in for a squared minus c squared is b squared. So I've got to plug that in. And because it's c squared minus a squared, it's actually the other way around. So I'm going to have the opposite of b squared. So I'm going to have x squared times the opposite of b squared minus a squared y squared is equal to a squared times the opposite of b squared. Kind of a long way to get there, but now I'm going to divide both sides by the opposite of a squared b squared. If I'd done this by planning ahead, I would have gotten rid of those negatives a while ago. So you can see the negatives cancel, the b squareds cancel, and I get x squared over a squared. Here the negatives cancel, and I get y squared over b squared. And then everything cancels top and bottom, and I just get 1 over 1, so this is equal to 1. And it took a while, and I'm not going to do that again, nor am I going to expect you to have to do it in an assignment problem, although it's always good for you to see it at least once. This is how I get the equation of the of the ellipse that's described with the information that I have above. Now again, notice that my foci are on the x-axis. I did that for convenience, and I had them equal amounts from the center, 0, 0. Well, that's how it ends up being this. If I put the foci top and bottom, I'm going to end up with something that's going to look a little different. I'm going to end up with something that's going to look like x squared over b squared plus y squared over a squared is equal to 1. And I'm going to get one of these two forms as long as my center is 0, 0. Now, I know that's kind of thrown right at you. You've seen it in Algebra 2 before, but I'm going to explain it in more detail in the next video. So hang in there, and if you wrote all that down, God bless you.